Hello, everyone. This is another episode of Weekly Live Contract Reviews. And today we're going to review a long requested contract. It's a Flux AMM. They requested it yesterday on Twitter. And I actually haven't looked in this. I did fork it for yesterday, and I was able to compile it, so we should be good to go. So let me present my C-line.
AMM, for anyone unfamiliar with the acronym, means Automated Market Maker.
Right, so it compiles, so this is already good. I guess I can try cargo test. So we look at the TOML first, and the TOML uses non-latest, or actually it uses not just a crate that we published, but some newer version that might have extra features, but it also re-imports Serde for some reason. Maybe it's to avoid TOML breaking, and it uses simulator, which is great. So this looks good. We check overflow checks true, which means it will panic if there is overflow. So let's start with leap. So there's a bunch of stuff, including a long mass that defines U to 56. And let's start with Flux Protocol first to see what's going on there. So just a bunch of imports. Okay. So there's a gas for compute, and okay, here's the main structure. It's called Flux Protocol, and it implements a new fancy macros and panic on default. So this is an unreleased feature for the standalone crate, but it actually does what it's saying. So if default on this is called, so it implements default, but it will panic if its default is called. This is needed just to avoid legacy near bunch and stuff. So it basically saying you need to use initialization instead.
You need to initialize it before you can call anything.
Yeah, and you cannot do default. So let's look at the structures. So there's account ID, markets, there's a lookup map, ID. So this is the last market. This is a pattern that in theory should vector support. So vector it in theory should be rewritten as like a vector of markets, but the problem is you cannot delete an element in the middle of the vector. So vector cannot have empty elements. So if you want to delete markets, this is the best way to follow token whitelist. I don't know what it is. Maybe contracts of the tokens that support it. We'll see. So when you initialize it, it takes owner ID and government account, but it doesn't use owner ID. So this can be changed to be valid account ID instead. And this one as well. So that will check validity of all accounts within token whitelist, which is cool. But then you need to cast it if you want to store it out of wallet.
Sorry, could you go? Actually, something that might be helpful for me is if you change it when you say you could change this to blah blah blah. Actually, change it.
Okay. Yeah.
And then maybe send a pull request or something.
My CPU is going wild, so I don't know if it's gonna be.
Oh, you just changed that to a type to show that they all need to be the same.
Yeah, it will just you don't need to validate them because they already validated automatically. And token map is so then you only need to cast it, and the way you do this is like you do dot into. Then token whitelist is needs to be also converted to be just account ID. And the way you do this is you can do a.into.collect. So it will infer types from what you need to do because it knows that token whitelist should be a vector of account ID. So collect will infer that this is a vector and account ID will be here.
So the a.into inside the map is changing a valid account ID generic into the specific account ID.
Right. Yeah.
And then collect
it
turns
converts,
it into the.
So valid account ID is just a structure of account ID. Into is actually just casts it. So it's like just return 0. Alternative, you can do, instead of into, you can do a0. It just returns you the first element. It's going to be the same. A is an input, so it's an element. Maybe I need
I
to
missed,
do
where were
into,
those other definitions? Sorry. Like when you showed me the code for into, I got lost.
I clicked on valid account ID and it went to definition of the valid account ID. This is part of near SDK under JSON types. So the way it works is actually cool.
Can you hover again in the original file? That's actually less disorienting. Yeah. Yeah.
Okay.
And then we just say what it does. So yeah, whenever you clicked around, I just felt disoriented.
So it doesn't take owner, we can do this. We can completely remove it for now. Okay, another comment is maybe we should optimize storage of the markets to be like something like M, because every key that has this prefix will have to use markets. Next is, so here's what happens. I needed into iter to convert it into iterator. So it's a draining iterator that like consumes this object. Then I map it to become a valid. It can also be rewritten as slightly different as a lambda. Something just for kicks. You can do cd into. So this is what canonical way of doing it will do. It will take this method and apply it to the object. This is also fine because it shows the type and converts it. Okay. Next, this view call to get the current gov account. Get pull swap fee. For the given market, it returns a swap fee. We'll look into this later. It uses U64, assuming there can be a lot of markets, which can or cannot be. It's fine to use U64.
Does that have to match something up the top? And does it? Like in the struct definition, with the vector. I forget what it used.
No, so this we cast it to U64 small, a lowercase, because markets get a regular U64.
There it is. Okay, that's what I wanted to cross-check. Thanks.
So we pull the market, and if it's not there, then we panic, which is usually how I like to write my get methods as well. We can look what's the swap fee eventually. So same here, get pull balances. It again pulls the market and get pull balances, which is a vector of U128, and we convert it to wrap it into U128. So again, the way to address this, since this is a copy, we can use into iter. It doesn't matter for this type. Then it changed the type from a reference of U128 to, so you can see there was a reference to integer, to the actual integer. Since this is an integer, we can actually use it as a copy, and that way you don't need to do references. And to cast it, you can also do b into. And these parentheses are not needed for this particular, it's a style preference. Or since this is already a copy of the vector that we don't really need, then we don't need to use a reference. We can consume this vector and just do this.
One small note is that the line 93 is trying to find a market that throws an error message that says no pool.
Instead of no market.
Yeah, seems like it should say the same thing. It's the same operation.
Maybe. Also, this is probably makes sense to replace into a constant. Let's see if my smart editor introduce constant file. Well, not so smart. And it only replaced one of them. Well, that's not exactly what I wanted. We can also probably refactor this piece out to just introduce a helper to return the market. So this can be
a non-public function called getMarket.
Yeah. Get expect. So it introduce this method. Sure.
And at this point, since you extracted the error message to a constant, I would think you could make the error message a little more descriptive without bloating and while keeping the contract size the same.
Maybe, I don't know.
It's a fine error message. Just seems like since you're not repeating a string over and over again.
Okay. I also prefer to move this type of stuff somewhere out of this main structure like here. So you have this non-public methods that never will expose a nearby agent on it. So okay, let's go back. Okay, this is fine. Outcome is U16. I don't know why is to even use U16. I also don't know what happens when you use JSON and you pass something larger than U16. Will it panic? This overflow checks or not? Or like silently die?
What's the
Oh, it's a target.
remind me of the cutoff size
Basically,
in JSON?
no, it's fine. So U16 is like 16 bytes, which is 65K. It's basically just outcomes, the number of outcomes. Okay.
Right. In terms of, like U64 is the largest JSON number without needing to use strings.
No, U120. Oh yeah, no, U64 already doesn't fit, but like partially fits. So like there's something like 53 bits or 52 bits integer that fits into JSON. I think Rust by default wouldn't care. Like you can actually pass it as a number and we'll parse it, and then there's extension that let you pass longer numbers. Okay, let's see. Just view methods, view method, another view method, another view method, and another view method. So there's just a bunch of view methods from market. Now we see the first change method, which is create market. So it takes a bunch of stuff. Description, outcomes. Why outcomes? Oh, it's a number of outcomes. Okay. Outcome tags, categories that I assume this market belongs to, when it ends, collateral token ID. I guess this is the token that you need to use for this market, and a swap fee. Okay, we first convert this to types that we want. Market ID self.id. Okay, this we assign a new market ID. I think at the same time we should also increment self.id, but so you don't forget to do this. Since if it fails, all of this is going to be reverted, so it's not a problem. It checks that this account ID actually belongs to the token whitelist, so we don't really need to check validity of accounts, but it's never an issue to do this again. So we can do like a valid account ID again, and do, since we need a reference, we can do as ref.
I didn't follow
We check that this, because this map, so this is just a set of accounts that is already verified on the top. So we already verified the validity of every account. We actually didn't, but now it is verified, so you don't need to do this check. You don't need to verify validity of that entry or do extra work because it's already checked.
So you can get rid of line 158?
No. You still need to verify. I mean, you can revert it back to where it was, which was just an account ID, not valid account ID. But it's a minor. You can just, for clarity, I like to keep it as is. So here it's saying you should use assert EQ instead of assert because it will throw helpful output and increase your contract size, obviously, for this helpful output. So end time should be nanosecond to millisecond. So I guess end time is in milliseconds. It should be more than a current block time in milliseconds. And if swap fee should be either 0 or within the limits of min and max. So max fee is 5%, min fee is 0.01%. Okay. We take the initial storage in order to pay for the storage of the market. We create a new pool.
Is there an assert greater than, assert less than, similar to the assert equal?
No. Well, maybe if you use some custom asserts. Okay, so creator's predecessor, bunch of outcomes. We log pool, that's cool. We create a new market, we pass what is payout numerator. Role once it's initialized, finalized, false. We log market, market status, insert market, increment ID, and refund storage. And return the new market ID. Cool, seems good. We may need to look into what's going on inside later. Seed pool. So I guess it's to provide initial liquidity to the pool. It takes market ID, total in, and some weights. Okay, this is just casted back to the original U120. So this is the pane that we introduced by using JSON, but not the standard types. So everyone uses U120 to operate on the balances, and the U120 capital to operate on arguments and outputs. That's why we need this conversion every time. So if you would just switch it to something like a strict balance, and a strict balance would be a type that supports arithmetics, but also does JSON serialization and supports stuff like yocto near, or like from yocto to near, stuff like round, and all the nth variables. Like, for example, you need to, when you refund it or touch deposit, it always would operate on this type. Then all this stuff that people have to do right now will disappear because it will just operate on a strict type, and you will always use it for balances. It will be as convenient to use as U128.
And it would cause no upgrade pain, right? Like if I have an account using the current approach and I want to upgrade to a new version of your SDK RS that has strict balance,
it will likely cause you pain anyway, but we can try to like avoid it as much as possible, like introduce costs from U128. But because here it doesn't use balance, right? It doesn't use balance type, but instead uses like, I don't know actually what the weight is, but maybe weight is not a balance. Anyway, so it gets the market, we can replace this into our new fancy get market ID. And it checks that the market is not finalized and the market didn't end because, okay, if it equals, then we seed the pool by passing total in and wait. So my question is like why we are not using, maybe you seed the pool in the token. So let's need to look into this quickly. Total in, total in. Okay, that's not very clear. Oh, it has to be owner, but there's no owner. What? Oh, wait. So you can seed the pool with the any amount because you just call it. Anyway, all right. That's not. You need to know more about what's going on behind the scenes to quickly understand what is total in. And like because you just minted it from thin air, you didn't pay for this. Then you just save the market back, which is good. And you refunded the storage. Exit pool. You take storage, you get the market, you get fees earned. Again, taking total in. You insert market, you refund the storage. And then if you earned more, then we will refund it to you from the token balance. If you didn't earn anything, then we'll return you true. So here I usually like to pass something like no deposit because it makes it clear what is this. But overall, this interface needs to change as well. And we discussed this in the past that this is super confusing because it combines three positional arguments that at the end that are destination, or like receiver ID, deposit and gas. And I always don't know which one deposit, which one gas. And arguments from the method that will be converted to JSON. So,
yeah, I find this very confusing as well. I forget, in a previous video, you said we talked about this. What's the plan for how this can be improved?
I don't think we should discuss it now, but it would be great if you can initialize it something like collateral token, something like new, then you pass maybe this three positional arguments, and then you can call transfer, and then you can pass this thing. And that will be better because transfer will have the strict types. This will be a trade that returns a promise. At least it's slightly better. It's not ideal, but maybe some way you can do this. It can also be a macro, so we can turn it into a macro, something like this. I mean, that's kind of, it still doesn't solve the positional arguments issue. but it's still better. Another way is like you can do just pass two variables by default, and if you need, you can do this deposit, and then you pass like actual this attached deposit, and you pass the amount you want to attach. So because by default, most of the time you don't need to attach any balance. So maybe this pattern is easier. So this is a receiver. Ideally, you don't want to specify gas, but probably eventually you will have to, like for a while you need to specify gas, because I don't know how to solve it without gas, but at least you cannot confuse a receiver and the gas amount. But yeah, maybe something like this.
Thanks.
And also, like Rust doesn't unwrap this macro until compilation completes. So this makes it hard to actually know which type to expect. If we
Yeah,
can
it doesn't have the markup in your editor that all the other methods have. Or the annotations, I should say.
Mm-hmm. And if you would just replace your trait, like so here's the trait. In theory, if you replace it with something like this, so it's always going to be a promise, then if we generate if you generate this kind of trait from initialization, then you will be able to do a.transfer, and it actually highlights these two things, right? And it will return you a promise. So if our macro or whatever we do in our magic generates you this, well, it's perfect because you have ability to see the arguments that you have. So you have types straight there. It's like verified by Rust. Plus it returns you a promise, which it should return anyway. So this is how we should probably address this. Then initialization of this, maybe we can do promise. No, it should be something like collateral type. Maybe it can be like promise. It takes the trait, and then it takes a receiver, and then gas. And you have promise with deposit, and maybe it has deposit, but it's kind of still doesn't solve the problem of this. But we have to use some magical macro, I assume, to generate this particular piece. Because you need this kind of implementation that takes arguments. Or maybe not, maybe not, maybe it's like, it creates an object with two extra, with another trait. So we can figure out. Okay, we only spent on this 5 minutes. But this is important for the future of SDK because this will solve this kind of confusion quickly. You can also wrap it into, so you don't need to like magically do this. Just do this. Yeah, just easier to write. return promise, sell, payable. So you take a market, collateral, outcome. So we get to the method where the users actually calling not, well, previously was liquidity providers, and this is users. So we get market, our magic auto replace solved that. I would replace this piece, it seems common as well, into something like market assert valid, or like maybe assert open, and then you implement these two pieces here into market. Where's the market implementation? Okay, there's no market implementation, so we can just implement it here. Assert open. And we need to move it out of self into pure. Okay, now if I search for this, I can replace this with market assert open. Well, that didn't help because I only found one place where I replaced it. Anyway, we will replace on the go.
Same for the nanoseconds to milliseconds helper. Did you already get rid of the self dot for all of those?
No, but anyway, so this one did not get replaced because it parsed args. Anyway, let's go up where we stopped. Let's sell. So it sells in a pool, collateral out, output target, max shares in, insert, refund, and it calls transfer again on a fungible token. Collateral out minus escrow. Okay. I don't know what's going on, so but let's keep it as is. Let me actually check my calendar weekly to check if I have anything today after this, so we can go a little over. Claim earnings. You say market, and it should return you earnings. I'm not sure why we do not return promise. Like, what's the problem for this? Like, you can easily just return promise like this.
Is there some early return, like Yeah, I was wondering the
Well,
same
there's
thing.
another promise to refund tokens, but not a big deal.
It just won't return that one, and we'll return the second one.
Yeah. Okay, claim earnings, another payable. Again, probably for storage. Market finalized. So yeah, so there we cannot really. We instead need to check that the market closed. So this probably would be, again, helpful to just move it to the market. So
We don't have to do that one.
well, it doesn't have to end. You can claim even while market is open, but not. Okay. Payout. So maybe if I use C-line, I should just, but this will create a formatting hell. So I enabled formatting on save. So if I save now, it will reformat everything using Rust FMT. But that will create like entire list of changes. So probably don't want to do this.
Do it in its own commit.
Yeah. Okay, so it does payout, probably returns how much to pay. Put market back, refund storage, logs some info. If payout is positive, we return promise, otherwise panic. Sure, makes sense. Okay. This is a vault method from the standard of 122. Let's see what happens there. So this is payload structure, and we parse it from JSON. And init struct function and args, and value is interesting. So this actually no idea how that's supposed to work, because value is variable value, and that's kind of cool. So it parses args as is and just passes it around. I personally don't like doing it that way. I would prefer if init struct was an enum, and that way it would be easier for me. So to tell what's going on, when this is parsed, it parses function as a string, and the second object is args. So it can be any type that just JSON supports. So it can be an object, an array, or string, or number, or null, or like anything. Then we do not parse it here, but instead pass it as is to corresponding method that we support. So publish, join, pull, or buy, and they will have to parse it on their end. So for example, publish pull. Then we parse the parsed args. So the challenge, okay, so this is private. Cool. So yeah, and then it just parse args using from args method that takes it from value, and it parses it inside. The problem
Seems like
is
it'll lead to hard to understand errors.
Well, it will still fail with the same error. It will fail error invalid args, which is not about error, because otherwise it would fail here, saying incorrect JSON. I would, yeah. So the way I would probably do this is to implement something like pub and init struct t to avoid error, and then you have functions which are these three. And you have publish, and then you either straight put arguments here, or if you don't want to do this way, so you can put, for example, market ID. Oh, what is publish actually? Publish pool. Publish pool expects LP pool. Join pool expects LP pool. Okay, so the way you would do this is you can use this. You can say publish gonna be LP pool. Join pool will be LP pool, and buy will be buy. So this is one way of writing this, if arguments are repeating itself. But you can also implement buy as a standalone like this. So this is also valid enum. And then when you parse this, you already have all the arguments parsed. You don't need to touch JSON again. And they equivalent. So the buy like this is exactly the same as buy like this. So they are not different from JSON structure. Anyway. Okay, going back to where we stopped, which is on vault. So it takes a vault ID amount and just passes it there. Because there are three methods, they need to handle it differently, and then it refunds storage. So this is actually what standard does not support. It doesn't let you attach a balance to the vault. And
what standard does not support?
122 and the new fungible token standard, it also doesn't let you to pass payable to the call. So until we finalize it, maybe good thing to revisit it, because if, for example, this implementation requires you to pay for the storage on this call, it may make sense to route entire deposit with the transfer call to the receiver. But then the problem is you need to handle a panic of this thing. So like you route the payable, and let's say this thing panicked, then your callback will receive the, or not receive, we don't know whether we received the call or not. So we cannot really do a refund ourselves. Okay, yeah, so that's the problem that we'll might need to raise and discuss in a standard. That's a main issue on the near protocol side. So the idea here is, let's say I create a promise and I attach 10 near with this promise. Then I have a callback on the result of this promise execution. When I receive my callback, I can check the result of the execution. If execution succeeded, I know that my 10 near gone. But if the execution failed, I cannot be certain whether my 10-year will be refunded or not. And this is because you can return a promise as a result. So let's say this thing returns this promise, right? It returns a promise. So if that promise will fail, I will keep the tokens that I already received here, but I will not I can still return a penny. So I keep the 10-year, but I also return a penny. So when a fungible token would receive a result from this method execution, it doesn't know whether it should refund tokens or not, the 10-year that was attached. So that's create an issue of 10-year can be lost. At the same time, this refund, like if any of this increases the state, then we cannot really charge it. So right now, this method is not payable.
What do you mean right now this method is not payable?
Well, this method will not ever receive a funding. Like it will not receive a payout through the current standards. NEP 122 does not attach a payment to this method, and the new standard, which is in NEP 146, it also doesn't let you to receive deposit through a proxy for the reasons of like unclear refunds.
So you're saying in the standards, this function is not payable. Here it is, but it's not going to work as expected.
Yes. Because the predecessor is a token. So this is also not checked here, which is it needs to check. So you need to check that the caller of this method is one of the whitelisted tokens. Otherwise, someone else might call this and pretend to be a token standard. Okay. And if a predecessor is token whitelisted, then it's not making payables. I think you should actually look at one of the methods and how it handles it. So publish pool, again, gets the market. So we can replace it with get market expect, and instead pass this. And it complains that this is, all right, yep. We check that the market is open. This is great. Assert collateral token. What? Oh, this is when it checks it. Okay. So this is where it actually handled. So that's why this one is not needed, because it's handled down the line and more exact check, because it verifies exact market collateral. Okay. Withdraw amount, so it calls publish market insert, so it refunds the market amount. So this doesn't change the storage, which is okay. So this method will work, and it returns withdraw from vault to ourself the amount. What is total in? Amount in. Well, it doesn't use amount in. That's a problem. So it doesn't actually uses the amount, whatever you passed. So long as you provided more amount than the total supply. Whatever. And then it withdraws the total supply, and the rest is refunded. Okay, you need to attach at least the total supply, and because how Vault works, we only withdraw the total supply that you need, so that's all fine. Okay, maybe we should look at the two others. Join pool. Again, we can use similar stuff. And then we can do market sort open. We verify collateral. So this actually probably makes sense to make it to the market as well, because it belongs to the pool of the market. Join pool,
Or
sender, and total in.
could add it to pool, right?
What?
Could you add it to pool? Market.pool.assert something or other.
Yeah. So that one actually modifies the storage, and that's why they needed to have a balance for this. And I think the solution to this is you first register your account on this pool. So this is the pattern of account registration that we introduced to fungible token addition. So before you can send token to the pool, you call something like register account on a given pool, and that will pre-allocate storage for your pool. For your account, it will have zero balance, and then you will be able to join the pool. Okay, so I went into get pool balances that actually iterates on a map, and I think it might be an issue because it might exceed the gas if there's too many pool owners. Oh no, it's on outcomes. Outcomes, okay, it's not users. Okay, boom, boom, boom. So what you do, you say remaining, you recalculate the outcomes because there can be many of them, and you pay it for each outcome. Inserted I. How that even works? If it's a vector, I guess just push. So we 1 hour in, and we may probably stop soon. So let's finish some, let's look at this piece to check what's going on here. Yeah, it does a bunch of inserts, and that's why it modifies the storage. So yeah, this is where you actually want to register your account first before you participate in some market. Yeah, I don't think we have that good pattern, like where a single contract handles multiple markets and accounts. So it's N by N, and that's why it needs storage at each call. Alternative for this may be per sender, you have allocated storage balance that you can use. And this is probably one of the modifications of the standard that we'll do. An idea here would be you once pay near for your storage of the markets, and then you have certain amount of storage on this contract that you can consume by your account, and it keeps track it instead of doing refunds every time you attach balances. So you like once paid, for example, 10 year, or like 1 year once we drop the fee, and that gives you 100 kilobytes of storage on this contract. And once you're done, you can force closure of this account, and that will erase your storage if it's possible. So,
or you could claim unused at any time.
Yeah, you can probably decrease the storage amount and claim the difference.
Would anyone
Okay.
who wants to transact in the fungible token need to do that?
Yeah, but that standard is much simpler right now. On the fungible token, we say you register just once, and you can check that it's registered. Maybe we can modify this as well to make it like this, because it seems like this pattern is somewhat superior. But then you'll need to keep track of the balance of the storage per user manually, which is extra bytes per user. So for fungible token, you don't need it because it's a fixed size. Okay, let's quickly continue on this, and maybe that means internal before pull token. Okay, that's a lot of logic that we'll need to look next time. And buy is similarly to sell, except it operates on tokens. So this can be changed again to something like this. Refund storage is a standard that takes storage and refunds it. And that's it. So the rest of the logic in pool and some other stuff, so we probably can review it slightly later. But yeah. The good thing we noticed, the problem that we'll need to think about is about the new fungible token standard and the storage. Yeah, so the way to address it is probably not through the fungible token standard that attaches storage, but through a separate account registration mechanism where you pre-allocate storage. And it might be common for some contracts that do this. So like, for example, I wanted to have a contract for identity management, which allows you to store variable data for your account. So I plan to use it somewhat similarly, where you can allocate storage and deallocate storage for your account. And we just keep track of storage related to your account. But the thing that I don't like is doing these refunds. So refunds are more expensive. Like you every time you do operate on the storage, doing a refund, like tracking the storage through a refund, increases the problem. Plus, making every method payable is also concerning. What we also doing for fungible token standard is some methods are payable because we don't want them to be able to be, we don't want to be able to call this method through a restricted access key. So let me actually stop presenting. So for example, in this case on Flux side, you may not want to sell through, well, you probably want to be able to sell, but there are some methods such as transfer to, which can be abused by some other app that you don't want to do. So, and the way we address it is we might make a method payable, but then we say, oh, you need to attach exactly one Yoctanir. So we say, if you attached more or less, if you attached more, that's bad because it means you spending your tokens on this. If you attached less, then maybe it's not. It was done through an access key. So eventually, you'll solve it with metadata, where methods can be marked as something like payable or some other name, which is
requires confirmation or something like that. I mean, that's the thing that you want is the reader. Like, you want to bug the user with a redirect in your wallet.
Right. And then when the wallet approves an access key to a contract, that contains a method that is marked as require confirmation, it will throw a big warning to you saying, oh, it is similar to add a full access key except for this particular contract. To do this, you need to type your account ID again because it may be dangerous and this action will potentially result in lost funds. And that will happen if you, that would mean that when you add an access key now, you will have to specify all methods names that can be called through this access key. So you will have to whitelist it if you have a method that is which is marked as confirming. Potentially a good solution for this would be to include exclusion instead. So when you create an access key, you have exclude methods instead of only include methods. And that way you can mark certain methods as like excluded from access key. But probably like, for example, for Flux case, maybe it's not a problem because all you can do is like sell to yourself. So like you exit the market. Still, it can be slightly like abusable. Anyway, for now, we're gonna have to live with some security like this. Cool. Thanks everyone for listening to this. That was a long episode. I hope you enjoyed it. And let me know if you want to review your contract next time. Thanks. Bye.